We appreciate everybody hanging in there with us. I know everybody's busy and has a lot to do, so we'll try to get through this as quickly as possible. So as Kevin mentioned, I'm going to talk about MBR system upgrades and replacement, and we'll do some optimization of your plant in there, and talk about various approaches that we can do. And then the first thing I like to start with is the operators, because really that is the most important piece of this whole puzzle when it comes to good, successful MBR operations, right? You guys are there day in and day out. Really the evolution of our product over the years and how we make things better is by getting feedback from all of you, and how we make things better and what works, what doesn't work. And so really that's the key to long-term operability, successful operations in our business. So what I like to do is, we try to reach out to all the existing plants as often as possible. If operators have turned over, if there's somebody new in place, we like to get in there and do some retraining if that's going to help out, or just get some, again, more feedback on what's working, what's not, and what we can do to improve. So operators is always the first focus in our approach. The next thing that we'll look at is the process as a whole. When we talk about MBRs, everybody's always consistently looking at just the membranes, but we really need to zoom out and take a holistic approach and look at the entire process from screens, your headworks performance. Hero pointed out in his presentation that a lot of the issues that we see can all be traced back to screen performance or lack thereof, and issues that we see there. So that can have a cumulative effect over the life of the plant. We'll look at the effluent quality. Is it where it needs to be? Are there some process adjustments that we can make in the system itself? Can we adjust the mixed liquor concentration that we're operating, or the aeration rates, the excess, the DO levels in the plant? So we'll look at all those things and make sure that we're fine-tuning the plant as much as possible. Energy efficiency is a big topic, obviously. As these MBRs are getting bigger and bigger, that's becoming a bigger part of the conversation. So we want to make sure that the process itself, the membrane operation, is being done as efficiently as possible, so we keep those energy bills down. Really, the ultimate goal is to only use the number of membranes required to treat a given flow. And if the flow is less than your installed capacity, well, then we will turn off part of the plant to match up the membrane capacity precisely with the influent flow, and we keep the plant as energy efficient as possible. We have about 350 operating plants here in the United States, and some of them are actually starting to get some age on them. We've got plants that are up to 20 years old. Many of them are actually operating on the original membrane units, but at some point it's necessary to look at replacing those membranes, maybe moving to a newer version that's more efficient, more space efficient, allows us to expand the plant. So we'll look at that. Pumps and blowers, particularly blowers, there are much more efficient pieces of equipment out there these days. And going back to that energy conversation, we'll start looking at some different types of blowers that can make the plant more energy efficient. They're easier to work on, they're quieter, just those types of things that we can improve the plant. And then instrumentation is an upgrade that we can look at. We've been retrofitting several plants by adding total suspended solids analyzers to let us know if we have a mixed liquor excursion within the plant. Or we can add some pH and ammonia analyzers to help us fine-tune the process itself. And really these tools allow the plant and the operators to be more proactive rather than reactive. So we can get some tools in there that allow us to look at things before they happen or as they're happening. Then that will pay off dividends in the overall operation of the plant. And then the control system. As you all know, the plant is controlled by a programmable logic controller. That stuff is pretty solid. Many of them have been around for a long time. They're rugged and reliable, so that's why they're still used. But really where we've made a lot of changes is on the HMI side, the interface that you look at your plant through, your SCADA software, your trends, your alarms, and things like that. So I'll talk about some of the things that we're doing there to make it easier to operate, and again, be proactive rather than reactive. So I talked about the operators. You guys really are the greatest asset for us. If you're not happy with what we're doing, then we need to try to correct that and make improvements. You know what the plant does and what it doesn't do, and so we'll look at your influent flow, your effluent numbers, and we'll try to fine tune the way the plant is operating off of that. I bring up training quite a bit. You know, we all, everybody on this presentation from the Kubota side has been in this business a long time. And so, you know, we understand that sometimes there's operator turnover and some new people come in. And so we need to get out there and do some training. And even for, even if you've been at your plant a long time, we still like to come back in and do training. We do events like this. Hopefully we can get back to doing them in person soon. But we just want to bring everybody up to speed and let you know what the latest evolutions might be in our approach with our products, our overall systems approach, and just give you some training to make sure that you're still comfortable with the plant and what it's supposed to be doing. So when it comes to an MBR, again, it's more than just about the membranes. It really is a group of subsystems, and we want to make sure that each of these is designed properly, first of all, but secondly, being maintained and operated correctly. And so the first one is the biological process design, right? We have to treat a certain amount of flow. We need to meet a certain effluent quality. So we want to look at that as a big picture item, make sure, yeah, is the plant doing what it needs to do? And if it's not, where do we go and look for avenues of troubleshooting? You know, Hero pointed out what we call the fishbone earlier, and really that's just a cause and effect diagram that we use to allow us to troubleshoot different parts of the plant. We have a fishbone for membrane performance. We have one for nitrification, denitrification, really each aspect of plant operation. We have these troubleshooting guidelines in place. Pre-treatment, talking about headworks and fine screens, and really the screening is the most important piece of equipment in the plant itself. Obviously, if your screens aren't working, you run the risk of damaging the membranes, but it's really a long-term effect that occurs. Debris that gets past your screens, or if there's an overflow, if the seals aren't properly installed and you just get carryover into the plant, eventually that debris will build up and accumulates. Hydraulically, you've got your inflow comes into an anoxic zone, then goes into your aeration zone, and then finally makes it to your membrane zones. And your membrane units are really like airlift pumps. So they're pulling down mixed liquor to the bottom of the tank, pumping it underneath and then up between your membrane plates. But if there's any debris in that pumping action, it will hang up on your diffusers or on the leading edge of your bottom membranes, or even get stuck in between the plates. And that's where the system will start to decline. You get accumulation, it'll build up, it gains a foothold, and now your membranes are getting fouled, your capacity is going down, transmembrane pressure is going up, you're cleaning more often, and then worst case scenario, it can really start to block off your membranes and keep your plant from working like it's supposed to. And that can all be traced back to screening performance. So it really is a key part of the overall equation. The other issue or other area is plant hydraulics, right? Most plants, the flow comes into a single point, but it has to be split to go through multiple process trains or multiple membrane zones. And so it's our job first on the design side to make sure that it's being split equally, whether that's through a splitter box or valves and pipes. We just want to check that the hydraulics are good, the velocity is where it's supposed to be. The ultimate goal is to make sure all the membranes are operating under the same conditions. We don't want one set of membranes operating at 5,000 mixed liquor and the other tank running at 30,000, because that imbalance will lead to fouling of the membranes at a faster rate than we need. So hydraulics is very important. We'll look at that. When it comes to aeration systems, we really have two in a typical MBR. We've got air for the membranes. Obviously, that's used to keep them clean, keeps the biofilm at the proper thickness that we're looking for, allows for cross-flow filtration on your membranes, allows the water to get through. It does that pumping action that I was mentioning. So it does a lot of things on the membranes. And then you've got your process air, where we're fine-tuning the dissolved oxygen in the system. Within Kubota MBR plants, the air we deliver to the membranes is actually being used, and it's a contributor to the overall system DO, but we'll do the fine-tuning in a separate aeration zone that we call a pre-aeration zone, and we'll typically do that through fine bubble diffusers. And then you've got solids handling, and really what I'm pointing out there is as we mentioned earlier, most MBRs will operate in the 10 to 15,000 milligrams per liter, and the sweet spot's somewhat in the middle. But every plant has its own personality, so some plants will work best at a little bit lower concentration, others at a higher. It just depends on your flow and loading coming to the plant. The key to remember is whatever that point is, we want to maintain it as consistently as possible. So we do that through frequent wasting. So a little bit each day or a few times per week is better than once per week or once every 2 weeks, because if you let your mixed liquor really start to go through excursions either up or down, that's where it can have an impact on fouling mechanisms that can occur to your membrane. So regardless of what we do with the waste sludge, we just want to make sure that we're wasting on a nice consistent basis. I did mention that the plants, the brain, if you will, beyond the operators is the PLC. That's doing all your automatic functions. And then on top of that, you've got typically a personal computer, desktop, touchscreen. That's the operator interface. If the computer goes down, the PLC is still running in the background in full automatic mode to make sure everything's happening as it is required. You just may not necessarily see it. So you have to walk through the plant and look at your local indicators, your flow meters, your VFDs to make sure everything's where it normally needs to be. The other part of the equation is your equipment selection. As I mentioned earlier, we want to make sure we've got the appropriate screening equipment in place. We have a preference for 2mm drum screens at Kubota. We've had good success with that type of equipment, and it does really lend itself to successful long-term headache-free operation. And then as we look at upgrading plants, we'll look at these newer types of pumps and blowers, instrumentation that's out there available that can, again, make the plant work better and be more efficient. And then finally, you've got your operation and maintenance. This is still an activated sludge process. So you've got your pumps and blowers, oil changes, belt tensioning, instrumentation. You've got quarterly calibration and checks. We do have the membrane component that's added in there. And if you look at your MBR as a box, and each side of that box is one of the parameters that we monitor. You've got your mixed liquor and your flux rate, air scour rates, and DO concentration, and screening performance. If each one of those, if we keep them in their respective ranges, then we stay within our MBR system box, and the membranes are going to last a long time. The plant's meeting its capacity. We're not cleaning all the time. So that's the ultimate goal, is to make sure that we're keeping everything in play. And when we start up the plant, come back and give you training, or we upgrade the system, we'll go through all these things again to make sure you're up to speed on what's required. So that's the system approach to an MBR. And the day-to-day things that we'll pay attention to, as Hiro mentioned, he talked about most of these. You've got your transmembrane pressure and permeability. We'll give you guidelines and thresholds about when it's time to make a change or do a chemical clean. Your air scour rate, that's very important to making sure the membranes stay clean. We're maintaining the biofilm. We're keeping that pumping action going like it should go. Pay attention to the permeate. Your plant is designed for a certain flow rate or capacity, and we'll typically size it up for a design flow and a peak day flow and a peak hour flow. We just want to make sure that we're staying within the design points on a day-to-day basis. We don't want to get in there and try to process more water than it needs to. For instance, if you have an equalization tank ahead of your plant and you just want to hold up some of that flow overnight and come in the following morning and run it at 3 times its normal value, yeah, that saves on some operation through the night, but it could lead to more faster fouling of the membrane. So let's let the plant do what it's supposed to do. We'll check the process aeration. And when it comes to DO in the system, we have found that just enough is the best approach to go with. We just want to make sure we're putting just enough membrane air to keep them clean, and just enough air for the DO requirement of the process, and don't waste. We want to keep the DO down as low as possible. Even if your plant does not need to denitrify, if we can set it up and operate as if it does, your overall plant's going to run much more efficiency. The process will be better. You'll have better energy efficiency, so that's the way to go. I talked about mixed liquor concentrations. Again, let's be consistent around whatever design point works best for your plant. And then Hiro mentioned these as well. Filterability, that test, we take the filter paper and we fold it up in a very precise Japanese way. But that's a really good go, no-go test on sludge quality. So if you can do that a couple times per week, It'll tell us a lot about the filterability of the sludge itself, and if we need to make some corrections to the plant, the biology, the membrane settings. So it really is a quick, easy test that tells us quite a bit. And then going back to screening performance, if we can do, we always recommend doing a coarse suspended solids test. It's basically a sieve plate test that we can do that will tell us a lot about how your screens are performing, how much accumulation of debris you might have in your system. So that goes a long way in long-term operations as well. Everybody hear me okay? All right, so when it comes to your process, part of our jobs here at Kubota is to visit the plants and just look at how they're operating and look for improvements to make them more efficient. So we'll look at your influent flow, your loading, your effluent numbers, and say, okay, where can we make an improvement? So we look at your mixed liquor, your air rates, your flux rates, etc. Sometimes the plants, they'll say they're designed, it's designed for 1 million gallons per day, but it's only seeing 250,000 gallons per day. If we're using the entire plant to treat that lower than design flow, first of all, it'll be energy inefficient because we're using more air, more membranes than are required. We also might have a lot more process volume than is necessary. So you end up with a really long sludge age, and that can lead to fouling mechanisms on the membrane. So that's one of the things that we'll look at is, biological calculations and look, will it help the plant if we take volume out of service? And so oftentimes that can be putting some bypass lines or adding some piping and valves to allow us to maybe take an aeration zone out of service, or do some programming changes such that we don't use all the membrane zones on a day-to-day basis. We'll basically make it such that we can turn down the plant, as I said, to match the capacity to the influent flow and try to pair those up as equally as possible. Chemical dosing, this is one thing that we look at, and I know some of you are familiar with some of these flux enhancing polymers that are out there. I really try to avoid using these until it's absolutely required. It really can become like crack for a wastewater plant. Before long, you're adding more and more of it, and really we're just trying to get over the hump if something abnormal happens or there's some sort of emergency that has occurred. But we want to get back to the root causes for why you're needing it to begin with. If your screens went down, you got a lot of solids in your system, or debris, mixed liquor's gotten too thick, your membranes have gotten fouled, yeah, the polymers can help, but we want to identify the root cause, correct that, and then get off the use of the polymer. And then sometimes nutrient removal will require some additional chemicals, either for phosphorus removal or a carbon source. If there's a change in effluent requirements, we may look at adding some of these chemicals to help it meet the effluent requirements that are the new target. And then energy optimization. As I said, a lot of it can be achieved through just pairing up the membrane capacity to the actual flow coming into the plant. So we're not using membranes we really don't need. Your most efficient point is to use the fewest number of membranes at the highest flux possible, and that'll get us through your day-to-day operation. And if you don't need the membranes, they basically go into a standby mode, and it turns into basically a duty standby piece of equipment, and the computer will keep track of the run hours, and we'll cycle them basically on a daily basis or every 12 hours to equalize that runtime. So on Monday, for instance, tank number 1 is the lead, and then on Tuesday it switches to tank 2. So it'll just go through that automatically. That'll help keep the process dialed in, but also the plant energy efficient as well. So equipment improvements, as I mentioned, there's a lot of older plants out there, and so we're putting in, there's a lot of these what I'll call older bar screens that are at existing plants, and even though on paper they're rated as a 2 millimeter bar screen, over time the bars get loose. As the rakes go between the bars, it starts to loosen up. So effectively you end up with a 1/4 inch or a 3 inch gap between the bars, and that's where a lot of the debris gets in. So if you do have those old little bar screens, that company's no longer in business in the United States, but we have identified options to replace them that are similar in size and economical approaches, but get us up to the screening performance that we like to see. Pumps and blowers, particularly on blowers, you know, a lot of you probably have the old positive displacement blowers that, you know, maybe they're 10 or 20 years old now and are not very efficient. There's a lot of new PD blowers out there that are really good. They're compact, they're quiet, you know, they come in their own sound enclosures, and they're really getting more efficient. They're also turbo blowers were quite the rage, you know, 8 and 10 years ago. I'll just point out when it comes to turbos, you need to be very careful with the selection and the application, because as compared to a PD, they have limited turn down. You know, a good PD blower is going to give you a 4-to-1 turn down, which is nice when you're talking about an MBR plant and optimizing its performance. But a turbo blower, the turn down is usually about 2-to-1. They're very sensitive to pressure and flow changes, so we just have to be careful with the application when we look at turbo blowers. But they can be much more energy efficient, and certainly they don't have any oil, belts. They're very quiet, so if they will be a good fit, then we certainly look at them. As I mentioned, adding instrumentation to allow us to have tools to be more proactive rather than reactive, so we can add TSS analyzers, ammonia, pH, things like that, that we can do that. And then again, we want to make sure the plant just overall is fine-tuned for matching the flow with the operating equipment. So if we can look at newer equipment, new screens, pumps, blowers, make your plant quieter, reduce the footprint, and ultimately make your life easier by reducing the operation and maintenance requirements. When it comes to airflow control, you know, the preferred setup is to have basically a blower dedicated to the service. So a blower dedicated to your membrane tank, blower dedicated to your pre-air zone, and you just put it on a VFD and you eliminate valves and airflow control valves. Like I said, we typically use positive displacement blowers because they do have a good turn down, but we can look at the approach there. When it comes to actually controlling the air, sometimes we do have a single blower that will supply multiple services, and we'll have airflow control valve, you know, they're actuated valves. So we just want to make sure that from a control standpoint that we're monitoring the air, we're controlling it. What we want to try to avoid is having one blower supplying multiple services through a valve, and some of the valves are usually mostly closed, and so you're bleeding a lot of energy across that valve, and it makes keeping the control, the pressure, the flow rate where you need to be. So we'll just look at that closely. When it comes to aerated zones, we want to keep them at a nice constant level, and I'm talking about good airflow control here. So that's why you'll see in a lot of our plants, we do what's called a pumping forward concept, meaning the varying levels in the anoxic zone, we'll use that to control the plant, and we'll pump forward into the aeration zone, and then it'll flow by gravity through the aeration back to the membrane zones and back to the anoxic zone. So that's the internal recycle. By taking that approach, we use varying level in the anoxic, get some partial equalization, but it does keep the aerated zones at a nice constant side water depth, and that does help with controlling that airflow, and we don't have a varying back pressure that shows up on the blowers. All right, equipment upgrades. So we continue to evolve our systems. What we do now is drastically different than if your plant's 15, 20 years old. And so part of what we'll do with our evaluation is look at where does your plant compare to current standard, our current approach, and we'll look at where are the areas that we can make improvements. You know, electrical actuators, eventually they are going to go out. And so we actually look at maybe upgrading those and doing a you know, what I'll call a top shelf type of actuator that will last longer and give you some headache-free operation. I've actually seen, you know, the failure of an actuator lead to a plant overflow or fouled membrane simply because it was a nuisance and it eventually locked up in a certain position and caused a problem. Flow meters, we'll make sure that those are working correctly and look at, you know, newer versions if that is an option for an improvement. I mentioned some of the instrumentation that we add to help you be more proactive again. And then I always recommend having spare parts for some of the critical components or critical control items. Actuators, right? I just mentioned they can lead to problems. Level transmitter, that's actually what controls the speed of your plant, if you will, is the level within the system. We'll put it into either a low flow, a medium flow, your peak flow settings. So that all is based on the level in the system. Pressure transmitters. This actually, I saw this question pop up in the session this morning, is how is the PSI measured? And we just use a pressure transmitter. It's in the permeate line downstream of your membranes, on the suction side of your pump, or just upstream of a flow control valve if you have a gravity only plant. But that pressure transmitter sends in a signal to the PLC. It reads the raw pressure, and then our computer, the PLC, converts that into transmembrane pressure. As Hero pointed out, that's the differential pressure across the membrane. So our computer basically looks at the pressure during filtration, compares it to the pressure during relax, and that's our transmembrane pressure. So that's a very key component. You know, we do have automatic shutdowns associated with TMP, and so if your pressure transmitter goes out, it's going to calculate a high TMP, and then your plant shuts down. So it's good to keep those on hand. All right, membranes. So we've got a full variety, a full family, and what I'm showing here is what I'll call kind of generation 1, if you will, with the 510 cartridges. And for those of you that don't know, the 510 just refers to the dimensions of the cartridge in meters. So that's a 0.5 meter wide by 1 meter tall. And then we've got the 515, 1/2 by 1.5 meters tall. And then on the right, we have our SP series, which is the newer version, and I refer to that as the Lego version of a membrane. Really, these modules have smaller plates within them, and they basically stack together and snap together. So they're very modular, and we're actually doing a lot of new plants with this membrane, but also some upgrades and replacements with the new one. So what we'll do is look at the specifics of your plant and figure out what is the best approach for the membrane unit that will work the best. We'll look at tank geometry, available side water depths, mixed liquor concentrations that are best for your plant, and that'll determine which unit we'll use. I will say that a lot of our installations have been upgraded that have the old style EK400, the double stack, you see that on the left. We've actually replaced that with what's called an RM200. It's a single deck version of the 515 cartridge, but it gets you basically the same capacity. It's in the same footprint, but it's more energy efficient. It is single deck, so it's easier to clean and maintain. And then for plants that need to expand or get more capacity, we've been switching over to, the SP version, because they are smaller but more space efficient with more membrane surface area. We can actually get more flow in the same tank geometry as compared to the other units. All right, so the obvious question is, when is it time to replace your membranes? And obviously if they're damaged, and as I mentioned, and really the first indicator will be high turbidity, or you're getting high fecal counts coming through your system. And what we'll do at that point is do a trial and error. We'll isolate it down to an individual unit, and then basically identify which part of the system is potential damage. And at that point, we'll have to do put some hands and put our eyeballs on the membranes and look for which membranes are damaged. And we can do some testing. The tubes, the membrane module itself is clear polypropylene, so we can use that to help us identify where we might see some sludge standing and help us get to the root cause of what caused that damage. As I mentioned earlier, oftentimes we trace that back to screening performance is really what causes these issues. Eventually, the membranes do get old, as Hero mentioned, and before we get to the determination of, do we need to replace the membranes now or can we wait, we actually will send the membrane material back to Japan and do those testing that he described. And we'll do some strength tests. We'll do chemical cleaning procedures to determine what's the best chemical cocktail that will work to recover the membranes. And if we are seeing some degradation in strength and cleaning procedures, and that's where we'll start having the conversation about when to replace the membranes and how many. Obviously, if you're going through a plant expansion, that's the time to look at newer membranes. And as I mentioned, many of the plants have done this over the last few years. And so we'll fine tune the membrane model that works best for your given situation at your plant. So we've got a lot of flexibility there. Oftentimes, just more efficient operation, as I mentioned. If we can put in a newer membrane that uses less air, has a higher flow rate capacity, that makes your overall plant operation more efficient, and then we'll get to that point much easier. And then system turn down, as I mentioned, if we can basically use fewer membranes to handle the flow, that makes the plant more energy efficient as a whole. And then as Joe mentioned on his plant there in New Jersey, we've been going through this a lot lately. If your existing membranes are just not working as advertised, if they're turning out to be not quite as bulletproof as you were originally told, then we have options and good success in replacing those other types out there as well. And then on the control system side, you know, as I said, the PLC is still what does the automatic function of the plant, and that really hasn't changed much over the year. In fact, a lot of the original plants are still using the original hardware. But where we have changed is on the HMI side, the operator interface. And this is a screenshot of an old plant from a long time ago, and that's basically the entire representation of your plant. You don't get any more information than that. This is our approach today. We use what are called mini trend lines, and so we can set up trends for all the critical parameters, and we can overlay them. We can custom configure that's best for your plant or information that you want to see. And what we found is, you know, a moving line grabs your attention much easier than just a wall of numbers. And so this is the approach that we're going to. And so a lot of these older installations, we've upgraded the controls to represent this newer operator interface system. Again, the idea is just to be more proactive and give you information before things get out of bounds. All right, so I'm going to go through just a couple of quick case studies of some plants that we worked on. A small plant here in Texas was having some issues. There was some hydraulic imbalance. The membranes were constantly being sludged up. They actually had a couple of overflow incidents, you know, short circuiting where flow was preferentially going to one side of the plant. And of course, all of that was blamed on the membranes. And so we went back and just looked at the plant again as a whole, looking at beyond just the membranes and looking at the root causes of the plant. So again, sludge, overflow, short circuit has got to be a problem with the membranes. And so when they were looking at this, they really just wanted to move away from the existing membranes altogether and try something new. And it really wasn't, that was not the case. It was fundamentals. The fine screens were not working properly. Like I said, they had a 2 millimeter bar screen that was not correct. So we replaced it with the drum screen. We corrected the hydraulics. We basically made, we split the plant in half and made it completely symmetrical such that the RAS return were both the same, and that kept the mixed liquor concentrations on both sides of the plant nice and equal. We replaced the permeate pumps to reduce the cavitation and make sure that it was really a good self-priming pump, and eliminated that airlock. Again, Hero showed you that video of air bubbles getting through the piping. And that's coming through the membranes. You know, you've got dissolved air and gases that are in the mixed liquor. And when you're pulling a vacuum to get that water through your membranes, it will come out of solution. And depending on the velocity of the fluid, it can build up in the pipe on the inside of the membranes and will actually air bind that flow of water. And so it will appear that you have high TMP when it's really just air slowing things down. So if we can make sure the pumps are efficient and good primers to pull that air out, it goes a long way to eliminating that possibility. And then we actually updated the control system again to our current standard to make sure they have all the tools available to them. So the fine screens replaced, permeate pumps, SMUs, we fixed the hydraulics, and we had to do it all while running the plant, keeping it online. So I worked with Hero and some of our application engineers and our project managers, and we came up with a really good plan to make that occur. So here's the old layout. It was unbalanced. Flow was coming in on one side, and it was not properly splitting the influent flow to both sides of the train. So we basically split it into two identical plants. Now they're completely symmetrical, and all the previous issues have gone away, and it's been running really great for the last 3 years. And then another case study is a bigger plant. Again, this is one of the older installations going back to 2004. Kind of a similar story, poor screens, sludging, foaming events, kind of a limited instrumentation and control system. And then the permeate pumps were cross-connected across multiple tanks, which kind of limited the system turn down and didn't really allow us much flexibility. So we went in and replaced the old EK400s with a newer SP600, and that's kind of a drawing of what it looked like. And so the membrane almost doubled, the membrane surface area had almost doubled. And even though the rated capacity of the plant didn't need to go up, this did give us more flexibility in terms of turning down the plant. And so now instead of using 4 tanks to treat the flow on a given day, now we can do it with 1 or 2 tanks. That increases membrane life, reduces cleaning frequency, and again, makes the plant more energy efficient overall. And then down the road, when it's ready to do a full-scale plant expansion, the membrane capacity will be in place, and we'll just have to look at adding some additional tankage for process volume. So kind of the same thing. We upgraded the system for the new equipment while keeping it online, and so that takes good coordination with the contractor and the Kubota folks, and we've got some good experience in doing that these days. All right, so replacing other membrane types. As I mentioned, we've been doing this quite a bit lately, and I'll just be honest with you guys, microdyne membranes seem to be the culprit there. We have quite a bit of experience doing this, and there's some issues just the way they're fundamentally designed that are creating these issues. But this is just an example plant, but some of these issues are showing up everywhere. The membranes are not capable of operating at their design flux rate and design mixed liquor points. And so what happens, you end up derating the plant. You have to lower your flux, lower your mixed liquor. And now the process as a whole is not working like it's supposed to biologically. And to compensate for that, you're having to add chemicals for flux or phosphorus removal. One thing that's a key component of Kubota membranes, it's a rigid plate with fixed spacing in between. So that prevents the membrane material from bridging across and touching. So that prevents the sticking together of membrane material. And what happens when the membrane sticks together, you lose that surface area. Now it's preferentially flowing through open areas, and then they start to foul faster. And then before you know it, you end up with membranes that are basically sludged up, as Joe showed in some of his pictures earlier. So in this particular case, we replaced the microdyne units with a newer SP series. And again, we've done this at several plants over the last couple of years. Really, it's been a pretty straightforward approach. The work has been limited to in-basin piping. So we'll make some changes to the existing piping, but we'll connect typically to the existing permeate and air headers. And we'll make sure that your pumps and blowers, everything's going to work as it's supposed to, but really the focus has been on the inside of the tank, and there's been very little external work beyond the membranes required to do this replacement. Here's just a shot, something similar you saw it earlier. These are SP450s that were installed into an existing tank. The old units were pulled out. We put in new mounting plates, new guide pipes. This installation, we did this twice at this particular plant. The contractor showed up on Monday, pulled the old units, got the system, the tanks cleaned out, and by Thursday afternoon, we had these new membrane units up and running. So again, it can happen in about 3 to 4 days. All right, I'm going to stick my sales hat on real quick, because I know there are some of you out there that maybe don't have an MBR, but are considering it. And I just want to point out some of the things that we like to emphasize at Kubota. We are microfiltration membranes. That means a little bit bigger pore size as compared to some others, but that does allow us a higher flux and higher mixed liquor concentration. And so that does give you more flexibility in how we design and operate the plant. In our world of MBR, there's always this perception about smaller pore size is going to give you better effluent quality, and that's just not the case. We did a lot of testing internally and also with some engineering firms, and what we found is microfiltration membranes can achieve the same log removal rates as some of these smaller pore membranes. It's the membrane configuration, the thickness of the membrane, the porosity of the membrane, and the biofilm that does a lot of the work. So we can get the same numbers. They are very easy to use. The cleaning procedures are very simple. We just inject the weak solution, as Harold mentioned, into the permeate pipe. It backfills the membranes under atmospheric conditions, so it's not under pressure. They soak for a couple hours. It's all very easy. Membranes and the mixed liquor stay in the tank. I just mentioned our geometry, rigid plate with fixed spacing. That's very important to how these membranes operate and keeping the plant running and keeping those chemical cleans to a minimum. Our membranes are made out of chlorinated polyethylene as compared to PVDF that a lot of others are. It's a much thicker membrane material. It's got better chemical compatibility, durability, and it results in a better filtration because the water has to take kind of a more of a tortuous path to get through the membrane. PVDF membranes are typically very thin on the outside, and the rest is made up with filler material. And then finally, we do design our plants such that the membrane zone is an active part of the biological process. So the oxygen we deliver, or the air delivered to the membranes, is contributing to the DO of the system. That results in an overall smaller footprint, greater flexibility for the process and the plant as a whole. And in conclusion, so our goal is to keep you engaged through these events, workshops, plant visits, operator training. We just want to understand, what's working in your plant, what problems have you been identifying, and what we can do to upgrade them. And we can come in and do some optimization in your plants. Oftentimes, it's really just making some set point changes to your controls. I've been to a few plants the last few years that were doing chemical cleans, every 2 and 3 weeks, and it just turns out that the numbers that were being used, the math involved was not quite correct, and we started doing the right numbers, and voila, the cleans are going out to every 6 months like they're supposed to be. And so really, I think the goal for all of this is to just make sure the plant is a great resource for everybody involved, the engineer, the operators, and Kubota. We just want to be a partner with you guys long-term in all of this. I appreciate the time. Let me know if you got any quick questions.